In this video, we will go over the atomic mass as well as the molecular mass of a chemical substance. So first, let's go over atomic mass first. The atomic mass is the mass of a single atom, and therefore we call this atomic. So the mass of a single atom. And the mass of a single atom of any substance is then compared to the mass of the carbon-12 isotope, because the carbon-12 isotope is our reference substance. And the unit of atomic mass is then called the atomic mass unit, which is abbreviated as AMU or simply U. And an atom gets its mass from the mass of its protons and its neutrons. So therefore, if we were to figure out the mass of any atom, all we have to do is figure out how many protons and neutrons that it has, and add the mass of those protons and neutrons together. And that will then give us the mass of the single atom. And because in atoms, in terms of mass in gram, it will be a very tiny value. Therefore, we do not use the unit grams. Instead, we use the atomic mass unit. So the mass of an atom, the atomic mass, is then equal to the mass due to the number of protons. Mass due to the number of protons plus the mass due to the number of neutrons. Add together. We do not care about the mass of the electrons, since the mass of the electron is really insignificant compared to the mass of the proton and the neutron. And the symbol of the atomic mass for the atomic mass is A, is then equal to Z plus the number of neutrons, or the mass of the neutron, is then equal to N. And the mass of any atoms, of any elements, is then listed in the periodic table. So by looking up at the periodic table, it should be pretty easy for us to figure out what is the atomic mass of any element. For an example, here is sodium, and this would be a typical box that we would then see on the periodic table. So for sodium, its atomic number is 11, and its atomic mass is listed down here. So in this case, 22.99. Now this mass in here is the average mass of the different isotopes added together already, and on average it is 29.99. Most of the periodic table that you will see may have more than 2 decimal places listed here in the atomic mass, and for some element we may have up to 6-7 decimal places listed. But here in this class, for simplicity, we need to carry a minimum of 2 decimal places. And in fact, we will try to round them to 2 decimal places. Let's now try a few practice problems. Please look up the atomic mass of this following element. So in this case right here, first one, magnesium. And if we were to pull out our periodic table, here it is, magnesium is 24.305. So if we can list this up to 3 decimal places, or we simply cut this after 2 decimal places. But then that's how we would be able to look it up. So 24.305. That's the value that we have seen previously on the periodic table. So here in this case, we can keep this in 3 decimal places, or again, round it to 2 decimal places. If we were to round this to 2 decimal places, this would then equal to 24.31. And lastly, please do not forget to include the unit. The unit here would then be AMU or U. So we can write 24.31 AMU or simply 24.31 U. And that will be the atomic mass of any element. Let's now try another example. What would be the atomic mass of silicon? And again, let's look up on the periodic table. So here is silicon right here, and here is atomic mass 28.086. And again, we can keep this in 3 decimal places or round this to 2 decimal places. If we were to round this to 2 decimal places, this would then equal to 28.09. And again, we can either use the unit AMU or U. They both imply the same thing. And now, let's move on to the molecular mass or the formula mass. Molecular mass and formula mass normally refer to the same thing. But we would use the term molecular mass if we were to have a molecular compound. If we were to have an ionic compound, then we cannot use the word molecular mass, and that when we will have to use the word formula mass. So formula mass is for ionic compound versus molecular mass is for a molecular compound, but they both refer to the same thing. And this is the mass of the molecule if we were to have a covalent or a molecular compound or the formula unit of the ionic compound. But that would be the mass of the entire formula, which is then equal to the sum of all of the individual masses of all of the elements that make up the formula unit. For an example, for a substance with a formula unit of AXEY, where A is the first element and E is the second element, or if we would have more elements, then we can add them in. And now X and Y refer to the number of atoms of A and E in this compound. To then find what is the formula mass of this entire substance, it will then equal to the following. So the formula mass is then equal to X times the mass, the atomic mass of the substance A. Atomic mass of element A plus Y multiplied by the atomic mass of the element E, and we add them together, and the units would still be in AMU or U, because the mass of an atom have the unit U or AMU. So therefore, when we add them together, the sum would still have the unit of atomic mass. Let's now try a few practice problems. What would be the molecular mass of CO2? And here in this case right here, we can use the word formula mass or molecular mass. Both would imply the same thing. But it's possible for us to use the word molecular mass here in this case, since this is a molecular compound. And to find the mass of CO2, it will then equal to 1. There's 1 carbon, and then there are 2 oxygen. And now we will then plug in their individual masses. 1 carbon, each carbon will then have the mass of 12.01 U, and 2 carbon, each carbon is 16.00 U. And when we add them together, this equal to 44.01 U. So that would then be the molecular or the formula mass of CO2. And now, another practice problem. What would be the formula mass of ammonium nitrate? And to help you with naming, let's try practice naming as well. This would then be ammonium nitrate. The NH4 here is ammonium, and the NO3 here is nitrate. So overall it is ammonium nitrate. Now in this case right here, can we use the word molecular mass of ammonium nitrate? Or we just have to stick to formula mass. So in this case right here, we cannot use the word molecular mass because this is not a molecular compound. This is an ionic compound. So in this case right here, we don't have a choice of using both molecular and formula masses, but only the wood formula mass would become relevant. And now to find its mass, we will then add up the number of hydrogen, and in this substance we will have 2 nitrogen, and we have 3 oxygen, and we have 4 hydrogen. So these are the elements that make up this formula unit. And adding all of this together, 2 nitrogen, each nitrogen is 14.00, 3 oxygen, each oxygen is 16.00, and 4 hydrogen, each hydrogen is 1.01, and they all have unit U in them, or the atomic mass unit. And if we were to add this together, this will then equal to 80.04 U. So that's how we will find the molecular or the formula mass of any chemical substances. And please try the rest of this to make sure you are able to do this on your own. And once you finish, you can look up online to find what the answer would be, to make sure that the answer you are getting match up with whatever we find online.